Hi, Year 10. Because we're missing a few lessons, I'd like to put some videos together, maybe a short 20-minute, 15-minute video each week, okay? If I then miss lessons, you can play that video and use it to fill in blanks. So we're going to start this video with the first three things on here, maybe four, okay? Starting with transformations, there's 3 or 4 topics in this list that we haven't done yet, okay? And we're going to teach it as we're revising for the mock. One of them is the first one, transformations. So to teach this, I'm going to use MathPad, okay? And there's some nice revision on MathPad. And we're going to start with the one that's in the mock, which is rotation, okay? So let's look at this question. Rotate the shape 90 degrees anti-clockwise about the point with coordinates this. Right, how you do a rotation is this. You find the... That's my oven. You find the center 2, 3, 2, 3, 2 across, 3 up, okay? And you put tracing paper over it, and you trace the center and the shape. So a blue cross on the center there and a blue tracing of this. That allows you then to turn, right? It's almost like you put in a pencil on the center and you're using the center then to turn it around that pencil point, okay? In this case, we want to turn 90 degrees anti-clockwise. Anti-clockwise is this way, okay? And I'll use the animate button, which will do it nicer than me. So here's a 90 degrees anti-clockwise turn. And now we need to find a way to draw that triangle in its new place by removing the tracing paper and keep on checking that you've got it in the right place. But I'm going to put the solution on there and remove the tracing paper so it's there, okay? The other one I'm going to look at is number 9. I thought this was quite nice. Rotate the shape 90 degrees clockwise about the origin. The origin is a posh way of saying the point 0, 0, which is right there in the center. Again, we're going to trace that point and trace the shape. If it was anti-clockwise, we'd be going this way against the clock, all right? Or if it's clockwise, we're going this way. And in this case, it's 90 degrees clockwise. So let's animate that. Turn, turn, turn until it's turned a quarter of the turn. And then again, remove the tracing paper and try and draw it in its new place there. Put the tracing paper back on and keep checking you've got it right. You'll be given tracing paper in the mock, but in this case, let's put the solution on there. Okay, that's rotation. Might do a bit of reflection in here, okay? Reflect the shape in the line y equals 4. Now, you've never seen this, okay? You've never seen this, but to draw the line with the equation y equals 4, you literally have to find where y is 4. So where y is 4. And the line y equals 4 goes across from where y is 4. So it actually goes in the same direction as the x-axis, which is confusing because it's a y line going in the same direction as the x-axis, okay? Then you've got to reflect that shape in there. Now I'm going to use red points again like I did with rotation. So this point, this corner here is 2 above the line. To reflect it, it would reflect 2 below the line. This corner here is 1, 2, 3 squares above the line, so we'll reflect 3 below the line, and all the rest I'll just do in black now, okay? So this corner here, again, 2 above needs to go 2 below, 3 above, 3 below, 3 above, 3 below, 4 above, 4 below, 4 above, 4 below, and finally 3 above, 3 below. And then I need to connect my dots up to reflect that. So let's just show that solution there. Okay, so it's reflected below the line. Let's try another one. Okay, this time reflect the shape in the line with the equation x equals minus 1. You're going to think that, well, x goes this way, but it doesn't. I need to find where x is minus 1. And this line goes down. That is the line x equals minus 1. Okay, this line here would be y equals minus 1, but that is not the line I want, okay? X equals minus 1 is there. Now again, chaps, take corner by corner. That corner there is 2 squares to the left of the line, so I'll reflect it 2 squares to the right. That's 2 to the left, 2 to the right. Let's use a different color. That is 1, 2, 3, 4 to the left. I'll go 4 to the right. 1, 2, 3, 4. I'm trying my best to ignore the axes now. I'm just using that line And again, that would go there. This one here would go there. And this one up here would go there. And show solution. There we are. Okay. Right. One more. Okay. Okay. Describe. Okay. This one, you'd be wanting to write what's happened here. So there'd be 2 marks for this. Okay. One for saying it's a reflection. B is a reflection of A. Then 2 for drawing in the reflection line. Right. That's the point. Let's draw the line, which is there. That's your mirror line here. And it'd be great then if you could say this is a reflection and the mirror line or the line of reflection is y equals 5. Y equals 5. So that's reflection. Okay. And the last one, translation. Right. With these ones, you get what's called a vector. Okay. The top number, translate just means move. Okay, translate means move. The top number tells you left or right. Okay, so if it's minus, you're going to move to the left. If the top number is positive, you're going to move to the right. So the top number, minus to the left, positive to the right. The bottom number tells you up or down. So 4 would be 4 up. If the bottom number was minus, it would be 4 down. So we're going to take a corner here. And in this case, we're going to move it 5 to the left. 1, 2, 3, 4, 5. Okay. And then we're going to move it 4 up. 1 up, 2, 3, 4. So its new position, I'll use a different color to show it. Its new position is here, 5 to the left and 4 up. And we would do that with every corner. But in the end, what we're looking to do then is draw it, starting here, in its new position. It hasn't flipped, it hasn't rotated, it hasn't reflected. It has literally moved 5 left and 4 up, and we'll do one more of these. Okay, sometimes it's better to do ones on grids, like they're very okay. Yeah, no, let's try this one. 3, 5. Okay, 3. The top number is right or left. If it's a +3, we'll take a point. Doesn't matter which point. We'll take this one. Right? It would be 1, 2, 3 to the right, and the bottom number is positive, so that's up. All right, 5 up. 1, 2, 3, 4, 5. Right. Again, I'll change that last one to red. You don't need to put the dots in. Right, just the last dot. And you could do that for every corner, right? So with this one, in fact, do you know what I'll do? I'll leave that blue, and then I'll take a different corner, right, with red, just to show you this corner here. Again, though, 3 to the right. 1, 2, 3, and 5 up. 1, 2, 3, 4, 5. Okay, you're kind of seeing where the new position of this is. All right, let's get a line and let's draw it there. Then it comes down 3, then it goes across 3, and then it connects back up. All right, show solution. There it is. Okay, so it's moving the shape. The top number tells you left or right, and the bottom number tells you up or down. You might get one that says describe. Let's get another describe here. Okay, so what you do here is go, okay, how do I get from A to B? To get from A to B, pick a point. Let's take this point here. Top point there. Right, to get to its new position here, how do I get there? I'll start with left or right. Well, I start by going 1, 2, 3, 4 to the left, which is -4, and then 1, 2, 3, 4 up, which is +4. So the solution should be -4 for 4 to the left and +4 for 4 to the right. Let me just nip back and have a look how much time I've got left on this recording. 5 minutes. Okay, so let me go now back to here, if you don't mind. Okay. So looking through some of these that you can try for me now. Rotation, you're going to need tracing paper. Trace the point, trace the shape, and you're away to go. Right? Describe fully the single, I should say. Let's change it while I'm here. Right? Single, the symbol, single transformation. Again, you're going to describe the rotation. You need to say it's a rotation. You need to say whether it's 90 degrees clockwise or 90 degrees anti-clockwise. And it very much looks like the center here is the origin, but you can check with tracing paper where the center is. Okay. All right. They are all rotations. Then translations. Remember, 5 would be 5 to the right. -2 would be 2 down. So for every one there, move it 5. This is an interesting question. What is the vector that would reverse it, that would take it back? So what's the opposite of 5 to the right and 2 down? Well, it would be 5 to the left and 2 up. So you need to write that as a vector. And then a few reflections. The line y equals 1. Remember, y equals 1. Y equals 1 is a line that's going to go across. Okay. Let me get a pen quickly. So y equals 1 is a line. I won't use, it's going to be a horrendous line. So y equals 1 is going to be in the same direction as the x-axis here. So this is going to flip down. 2 above becomes 2 below, etc. Okay. Whereas if this was the line, let's just quickly draw it. So the line y equals 1 would be that way. Whereas a vertical line, that would be x equals 1, would be that way, okay? So a couple of those for you to try on reflection. There we are, there's one with x equals 1, which is slightly different. And hopefully that guides you through that, okay? Super quickly, I want to move on to changing the subject of the formula, okay? A couple of rules here, chaps, right? Let's make k the subject of the formula, but let me do a slightly different one. Let me do z equals 4k minus 8, right? If I want to make k the subject, I want to leave k on its own. So I'll move the minus 8 over this side as a plus 8. And then the times 4 would come over here as a divide by 4, leaving k isolated. Now it's the subject of the formula, it's by itself. Okay. Problem with the one down here, make g the subject of the formula. Let me do one similar here. Let me go for z again equals 9 minus 8g, or even, minus 8g. The problem with this is I don't like the fact that the subject at the moment is negative. It's minus 8g. So to make it positive, I'm going to bring it over to be positive 8g to join with the z that's over here. And I'm going to then move the z in the other direction. So the 8g has come over here and the z is over here as a negative. Okay. Again, to isolate the g, take the 8 instead of a times as a divide. Now you try that one there. That one's okay. And finally, make x the subject of the formula. Here's my version. 4f plus 11, right? I need to expand this bracket. 3 times x, 3 times a. Now, leave the x is positive, so leave it where it is. Let's move these, right, over here. So over here, I've got 4f equals, my apologies, I've got 4f, I've got the plus 11, and I've now brought the plus 3a over as minus 3a. And finally, all of this, including the minus 3a, needs to divide by, you always end with whatever's before the subject goes over as a divide. Okay, try up to there for me. This will be a good start for this week.